Hi there, welcome back. Today I've got a rather unusual radio to repair, one that I have never seen before actually. And when I did some research, I realized that my ignorance had come to the fore because this thing is actually pretty well known to the people in the know, um, as it's quite an iconic little radio from the 70s. It's a Brionvega model TS505 FM AM radio. And this particular brand became quite renowned for its rather avant-garde designs, mainly due to the influence of two designers um, who started working for Brionvega in the 60s and 70s and turned the rather staid and although quite old company around in terms of design. And ironically, it's actually in the same train of thought as the radio you see in the background there, which is the Braun Atelier 3, designed by the famous designer Dieter Rams. So it's actually quite unusual that I get two iconic radios, one after the other, landing on my lap. The designers were a guy called Mario Zanuso and a gentleman called Sapper, who created this rather minimalistic cube that opens up, or rather closes up when not in use, and doesn't look like a radio at all. When you look at it closed, it's literally a little cream cube that sits on your bench or desk or wherever, and takes you quite a bit of imagination to imagine that it is actually radio. Then you open it up, and you get access to the speaker and to the dials and controls and so on. Now this one came in, it's not working, and it's got no reception. There are no lights to light up, sticking to the minimalistic theme. So there actually is no indication that this thing is operational or how it operates at all. It works on six batteries, so six 1.5 volt batteries, so 9 volt supply, and it also has an AC power cord working on 220 volts in this case. So the first thing to do is open it up and get to the insides and see what we can do about this. So what I've done so far is I took it all out. I didn't desolder the headphone jack, as I said, and I had a look at the schematic. And what we have really is two sections, the power supply and the power amp section, the radio section. So what I've found on the schematic, it's pretty clear. There's something called bassa frequenza e alimentazione or something, which means low frequency and supply. And that is in this dotted line over here. What we have coming out of here is a connector, white and a black, going to the headphone socket, and then from there going to the speaker, which is what we've seen on there anyway, coming out of this section. So it's coming out here. There's the white one, there's the black one. They go off to the audio outputs. And then over there we have the mains connector, which I took off earlier. There it is. We have the battery connection, which is these two wires over here, black and red. And over here we have one connector, which is in here. But this connector is connected to this section through the hinge. There are three little wires going through the hinge. And all we have here is ground, pin 5 there. We have 8.2 volts, that's point number 6 there. And we have BF, which is bassa frequency, which is low frequency, goes into a 1 microfarad 10 volt capacitor. So that's the audio in. So it seems that it takes power to the radio section and has one line coming back together with the same ground, which is the AF. And that AF then gets amplified by this chip over here, TCA 830S. And the outputs of that obviously go to the audio outputs. Now, what I've got to do, I'm going to just test this point over here to see if I've got voltage. And then I'm going to see what happens here if we're getting any audio out. Let's just check the voltage first. Okay, so I've connected 9 volts to the points here where the battery comes in. Remove the battery obviously, but I've connected 9 volts in there, and I'm going to test between ground and that point there, which is the red wire, Rosso, and this is black, blue and red, and that's exactly what we have coming out there going through the hinge. And I'm going to check if we get the 8.2 volts over here. So 9 volts in. Let's see what we've got over here. We've got 9 volts coming in, that's fine. And we should have 9 volts on the red wire. We should have 8.2 volts over there. And I'm getting half a volt, which is great news, because that means that the main problem is that there's no power going into the radio. And if there's no power going into the radio, obviously I'm getting no audio out. Now, if I touch the BF, the input to the amp here, I hear a buzz. So it seems that the audio amplifier is working fairly well. So I decided to prepare to go one step further. And that is, I've got a signal generator with a 500 Hertz signal, sine wave. Connect the ground to there. And I've got the generator coming out. I'm going to make it very low. I don't know how sensitive this is, so I'm putting out 10 millivolts RMS at 500 Hertz, and I'm going to put that into the low frequency input and see if we get a tone. Let's try that. Yep, we've got a tone. There's some oscillation going on, but there is a tone, so that's even better news. So what we have is, we have the power supply is not providing power to the radio board, but it is providing power to the amplifier board, and the amplifier board is working well. I put a tone in and I get a tone out of the speaker. I'm putting in 10 millivolts RMS, so there's quite a lot of gain on this. This, I believe, is a 1.6 watt, if I'm not mistaken. I saw that somewhere. I believe I saw that over here. Where did I see that? No, it doesn't say here, but I did see it somewhere. I believe it's 1.6 watts that's supposed to come out. So The PA is working, power amp's working. The power is arriving at the amplifier. There's some buzz going on, but it's not getting out to the radio board. So that means I've got my problem isolated. The first problem is isolated to this section over here. And that's what I'm going to check next. My guess, it's also smelling a little weird. Yeah, definitely a smell. Can you smell that? No? Damn, the internet hasn't developed that far yet. Right, there's some smell going on here. And my guess is that either a diode has gone or a capacitor has leaked. And that's what we're smelling, the dielectric. I think this smell, well, I'm going to say it anyway. I think the smell smells of diode. I'm not sure. Anyway, I'm going to isolate these two sections. I'm going to desolder those 3 points over there so that I can work more freely on this. And I'll probably have to go and probe around here, see what signals, what voltages we're getting. My guess is either a diode has gone or one of the capacitors have gone. Now, I do notice there's a buzz, there's a hum. So my guess is that the capacitors are a little bit beyond their due date. And I may have to just recap it, but they're not many. There's electrolytic capacitors, the main filter cap here. We haven't tried the mains yet. So there's a main filter cap over here. There's 1, 2, 3 electrolytics. Low voltages, they're 10 volt electrolytics. A little bit risky, I think, because this thing's working on 9 volts. Putting a 10 volt capacitor there is probably asking for trouble. They're all 10 volt capacitors. Damn. With the exception of this one, which is 25 volts. That's the main filter cap. But it's pushing it a bit fine, I think. Especially since I believe on the schematic we've got supposed to have 14 volts over here. Schematic's pretty simple. You've got AC going in, there's a fuse, comes in, fuse, power transformer, then you get a full bridge rectifier, 22 N capacitors to ground across all 4 diodes of the bridge rectifier. So they're trying to isolate any RF noise going back in or any noise coming in through the mains. There's ground, and then you have the positive coming out here at 14 volts. Now 14 volts coming out here, it goes, you got a 16 volt capacitor. They say 16. Yeah, it is 16, not 25. You got a 16 volt filter cap for a 14 volt supply. Now, that doesn't sound right. I mean, the peaks of this thing are probably going, that's 14 volt RMS, or rather DC. This thing could be, yeah, this thing could very well be sending peaks above what the capacitor's rated for. So there's a diode over there. This is probably polarity protection of sorts. Small resistors, 39. There's a Zener diode there of 8.2 volts. That's the guy that's actually sending power to there. So my guess is that we should look at this point over here. 8.2 volts, that says 8.2 volts. That's the direct connection. There's a 100N cap over there, and that's not getting to that. So I'm going to have a look at this and see what we've got. The smell could well be, if this thing is shorted to ground, the smell could well be that diode heating up or that resistor heating up. In both cases, that's not very good. Wouldn't do it any good at all. So I'm going to check that point over there, see what we've got. So following the theory that we could have a diode problem, or resistors, could be one of those, could be those diodes, that resistor, that Zener, could also be that shorted, but I doubt it. I had a look at the diodes, and Let me show you. Actually measuring them in circuit. There's one there. So I get the diode checker says 0.52 forward voltage, that's fine. There's another one there, that's 306. That one 0.51, that's fine. And I was looking for the other, the Zener diode. The resistors are fine as well. I'll tell you, that's 302, that is supposed to be 39 ohms, it's reading 40 ohms, that's fine. And that one is supposed to be 39 ohms, and that's 304, and that's reading 39.5 ohms, so spot on. So I started looking for that Zener diode, and I couldn't find it. There's this mess over here, all in black, which is a pretty good hint something went wrong there. This is a ferrite core, or ferrite tube, inside which is a component that seems to have melted. So I desoldered one point on there, and when I pulled it up, this is what happened. It just came apart. There's the end of the Zener diode, and this is where the other end is, somewhere in there. So here's our culprit for now. Somewhere here we should be able to read the designator for the diode, which is D302, an 8.2 volt Zener. Because there's all that gunk that melted there, I can't read it. So what I'm going to do now is I'm going to clean this part up, and I'm going to remove the rest of that Zener diode. And then what I'm going to do is I'm going to power it up again without the Zener diode, because what the Zener diode actually does is it is protecting against overvoltage. It actually forces it. Here we go. That is effectively a bias resistor for that Zener diode. So it provides a bias voltage there, and then the load goes off there at 8.2 volts because that's reverse biased, providing the 8.2. If I remove that, what I'm actually getting is that 9 volts that I've got coming in here minus the diode drop. So I've got 9 volts coming from the battery line that I've connected, goes in there, there's the diode drop, and it comes across to here and out as 8.2. I think what I'm going to get is 8.2 anyway, because 9 volts in there minus about 0.6 comes about 8.4, say. So that Zener diode would be reverse biased with very little excess voltage to drain off on that resistor. And I think what's happened is this thing is shorted, and because it's shorted, all the voltage drop was going through there on that 39 ohm resistor to ground. I actually expected that thing to be dead, but it's not, surprisingly. It's held out and maintained its value. So I'm going to switch it on again with 9 volts in the battery supply and see if I get 8.2 over there. Let's have a look. Oh, got to switch on the supply. .4, exactly. So that Zener messed us up, and that's all that's wrong with it. It was there just to protect against overvoltage, because the battery really provides 9 minus voltage drop, and I'm saying 9 when the batteries are full. So that Zener there was just a protection, really a last resort to protect the radio section from overvoltage, and it's blown. So I'm going to see if I've got an 8.2 volt Zener, and we'll take it, put it in there and take it from there. Then I'm going to recap it anyway, but we'll try it once I've done that. By the way, I did disconnect the other section from here, and all it took was desolder from here, desoldering those 3 wires, there's the PA, the power amp is actually working. Switch that off. And the hinge actually screws on here with 2 screws and nuts. Very simple. The wires then come through the hinge over there. So I'm going to get that Zener in there and see if we've got the main problem solved. Following the loss of a couple of videos that I took in this restoration process, I've come to the stage now where this thing is practically complete. And I'm going to walk you through what it is that I've done. The first thing I did was replace that Zener diode that was blown and that had spilt all the gunk on the board. That's that guy over there. It's an 8.2 volt Zener, and it had actually broken apart. So that was replaced with another 8.2 volt Zener. And what I'm going to do now quickly is show you what voltages we get on there now. So switch that on, and 8.11 volts, perfect. The other thing I did was, so we've got the right voltage now coming in, coming out through the power supply section and going to the radio section, which is this side here. What was done then was I had a look at some of the capacitors on there, electrolytic capacitors, and I removed a couple and measured them, and they were all pretty much out of spec. So I decided to recap the whole thing with one exception, which was actually quite fortuitous, and that is that the main filter cap over here, it's 2200 microfarads at 16 volts, is actually perfectly fine. It reads 2300, which is just about right. There's very low ESR and there's no leakage. I tested everything. So I think we got something like 5 microamps leakage at 16 volts. So it's pretty much perfect, and it's just as well because I didn't have one of those handy, and so I didn't have to wait for components to arrive. The other thing I want to show you is that this is quite an amazing cap because it's actually got quite a high voltage across it. If we measure the voltage there, .94. It's supposed to have 14, it says, which is damn close enough. So it's got 14 volts with only 2 volts to spare in terms of excess. Now, because this thing is the filter cap, I would have expected it in modern equipment anyway to be, you know, something like a 25 volt or even a 35 volt cap. It's a 16 volt cap, and yet it's held out pretty well. It's just testament to some of the quality that guys used to build back then. If it was today, the cap would be a third of the size, but I would put double or 3 times the voltage rating just to be safe. So we have the pros and cons there right away. Now, let me show you the capacitors that have been changed here. All the electrolytics have been replaced. So there's the main one that is the DC, it's a decoupling cap, it's a coupling cap, DC blocking to the speaker and headphone. It's actually quite a hefty cap. It's 470 microfarads, which is quite unusual and usually high. If you're looking at an 8-ohm speaker, you're looking at a cutoff frequency of something like 0.01 hertz. So that's probably overkill, and which can have its detrimental effects as well. It does allow all bass to go through, but it probably allows too much bass to go through. So if you get any rumble or, you know, really low notes on the reception, you could get a vibration on the speaker that's probably not something you want to hear. But anyway, it's been replaced with the same value, high voltage rating, of course. All these are 50 volt capacitors, Panasonic FCs. So there's another one. There's another one. There are 2 100 microfarads ones over there. So all these were replaced and the board was cleaned up both on the top side and the bottom side. All the solder connections cleaned out as well. So this board was totally gone over with a fine tooth comb, or should I say a cotton swab with isopropyl alcohol, and everything was properly cleaned out. The switch down below was also cleaned out with contact cleaner. It was a bit scratchy and it failed sometimes. So that has been given a total revamp. Staying on the same side, this whole chassis was, let me switch that off, very well cleaned. It was a little dirty, not too bad, but it was dirty. So that's been cleaned out, and it now has a totally different look to it. If we look on the inside, it's rather more presentable. Okay, now, same thing was done with this guy here. This is the other side with the antenna in it. This is the one that houses the radio. And I'm not sure if I pointed out that the antenna was completely stuck and had no cap on the top. Now, proof that you should never throw things away, I found this little black cap, which actually matches very well to some of the black fittings that are on the sides there, and the antenna was loosened up, so it now works perfectly fine. It extends and it works perfectly fine. So that's that. As for the radio section, it's also undergone a bit of a facelift. Everything was cleaned out, all the grime removed. The switches, this switch here is what changes between a level detector for the tuning. So you get a tuning level detector both for FM and AM, and also a battery check at the top. So you switch one way for battery check, can't quite remember which one it is now, but you can see it straight away once you get it working, and you switch the other way for the level detection. This here was a high-low tone control. So low is down, you get more bass, high, you get more treble, and on receiving FM, that's actually where it should be. Needless to say, the reception is perfect. The two things that I could not do, by the way, all the switches were oiled, cleaned and oiled where necessary, as was the wheel, the inside part of the wheel on the tuning cap. Just a little drop of oil over there. Everything cleaned up in here. I didn't change any components in here, and I'll tell you why. There are only two electrolytic capacitors in here, and those are the two guys down there. They're both ulnar caps, and this part of the circuit where they are in, I don't expect them to have gone through any kind of thrashing. And removing them would require me to dismantle this whole thing, at least to remove them properly. And my guess, after testing the function, is that it's damn perfect as it is, and there's no point in trying to mess with something that's working well, because all you're going to do is probably cause a fault during the process. Right, these sponges, everything that are sponges on here has been replaced. The sponges were completely dried out, as I showed in the pic in front. This was also replaced here, these sponges. There's another one on the speaker. And so the switches were lubricated and cleaned, or cleaned and lubricated. And the fascia got a complete cleanup in detail. The two things I could not repair. One is this hinge over here. There's actually a cracked section of the hinge. Now, to fix that, one would either have to have the original piece, which I don't, or you'd have to build it up with some kind of epoxy, and my guess is that you could probably end up with a frozen hinge. So I'm afraid that one's going to have to stay as it is. The other thing is there's a slider knob over here missing, the volume control knob, and that I don't have either. Maybe the owner has it somewhere and can put it back in, or we could try and find one. So all I need to do now is solder these two through the hinge. This goes through the hinge over there. Put the hinge back, solder these three back on. This is the negative supply, positive supply, and the AF out. And put this back in and show you how it works. And it works pretty well, I can tell you. Oh, and of course the antenna lead at the back goes to the actual antenna in the rear of the unit. So let me do that and get back to you. So here we have the little guy back together again. And as you can see, it looks brand new. A little bit yellowed over time, so the white plastic doesn't show up that much on camera, but it is in fact just slightly yellowed, which gives it a more mellow look actually. And the handle has been cleaned and corrected, works perfectly. You pick it up like that. It actually balances quite well too. So handle hides in there, the antenna works well, and it actually can come up so that you can turn it around. So antenna fixed, and once you open it up, there we go. The guy's working perfectly. Let's try it on. Hit the power. Okay. Volume's a bit high. Halfway. There we go.
Desde que habito aqui, levanto a cabeça e avisto a montanha. Baixando-a, escuto as fontes. Con otro tipo de ciencia.
Claro que no. Y además aquí es muy rotundo. Dice que nunca.
That's actually a Spanish channel from Canary Islands. You have the high and low.
Ellos cargan de todo tipo de reformas, atienden la necesidad
That's
del
the tone
profesional
control,
y particular,
high
material de construcción,
and low,
a granel
so the
y en
bass
bolsa,
is
arena,
attenuated, the
revuelto,
treble cut.
arena montaña, bloques, cemento,
Of course, this is
mortero,
all on FM. Let's try medium wave. We've got a ferrite antenna inside, which is directional, but we don't get much here anyway. There we go. Long wave, don't expect anything, but it's working. I very seldom get anything on medium wave here anyway. And let me show you the front and show you what some of these controls do. Right, so put the volume down. Here's the long wave, medium wave, FM selector. And if you look there, let's put it on high. Let's get the volume way down. If you do that, you'll notice the meter goes to the green straight away. Obviously, it's this is the battery status meter, so it gives you an indication of where your battery is by selecting that switch. If we put it back up, it's a tuning indicator. It just swings a bit on FM. And if we go on medium wave, it's down to 0. On FM, of course, it's left and right indicator, with the center being the optimum position. On the AM bands, it goes down to 0, and when you get near a station, if we can, it's very weak, but it gives you an indication of the signal strength. There's a null station, it's gone up to 4. Well, can't really show a meter when you don't have any FM, AM stations to tune into. But you get the idea. Volume control over there, and the on-off switch over there. Now, this guy is actually quite amazing. It uses some ICs for the power amp. It actually uses a chip for the power amp. This was built apparently in '75. And we have 2 ICs on here. This one here is TCA 830S, and that's the power amp. I've actually found a data sheet for it. It works up to 20 volt supply, so that's why and it's quite powerful. I can't remember exactly, but I think it's about 7 watts. So it's quite powerful in this, and it's working perfectly. So that's the first chip that's on there. The other one is on the AM frequency, the intermediate frequency detector, and that's over there. That's a TAA 991D. So they've used those in there. They've got the usual IF transformers, very similar to what you'd find in most radios of the time, and even today. So everything else is pretty standard, except for the use of those 2 chips, which I hadn't seen. I hadn't seen those chips before, those particular ones anyway. It's a very neatly designed and constructed radio. I'm talking technically now, because in terms of the mechanical and the actual industrial design, I think it's beautiful. I think this thing is absolutely great. I'd never seen one of these before. I'd never worked on one of these before. It's a pity, in fact, that we can't get that hinge fixed. But let's not give up just yet. I'm sure something might come up, or an idea will come up on how to fix that with putty or resin or something of the sort. So that's it. It's working on the main supply at the moment. The power cord actually fits nicely into the back where the speaker compartment is, so you can hide that away. And this is good to go. Right, I hope you enjoyed that, and see you soon.